Welcome to The Explainer. Today, we're diving deep into one of the most elegant and complex processes in human physiology, the menstrual cycle. It's this incredibly coordinated symphony of hormones and physiological changes, and understanding it, well, that reveals a vital sign of overall health. It's a rhythm that requires this seamless conversation between the brain and the ovaries. So let's break down exactly how this intricate dance unfolds.
All right, so we're going to start at the top with the command center in the brain. Then we'll walk through the preparation phase, the main event, ovulation, and the waiting period that follows, before looking at how the whole system brilliantly resets itself for the next month. So the entire show is run by what's called the hypothalamic pituitary ovarian axis, or HPO axis. Just think of it as this constant back and forth conversation between the brain and the ovaries. And the primary goal of this whole chat? To carefully select and release just one dominant egg each month. It's a classic top-down command structure. Right at the top, you've got the hypothalamus, acting like the conductor of an orchestra, sending out the main signal. That signal goes to the pituitary gland, let's call it the lead violinist, which then directs the ovaries, the rest of the orchestra, to produce the actual hormonal music of the cycle.
Okay, now here is where things get really, really clever. The hypothalamus doesn't just send a steady stream of its signal, GnRH. It sends it out in these rhythmic bursts, or pulses. And this isn't just some minor detail, it is absolutely mandatory. A continuous flow would actually make the pituitary just ignore the signal, shutting the whole system down. So these pulses, driven by some very specialized K&D neurons, are the absolute key to everything. And here's the genius of it. The speed of that GnRH pulse tells the pituitary which hormone to favor. So a faster pulse, say about one every 90 minutes, promotes the release of luteinizing hormone, or LH. A slower frequency, that favors follicle-stimulating hormone, FSH. This ability to change the tempo is crucial for controlling the cycle's very different phases.
All right, let's move into Act 1, the follicular phase. This whole phase kicks off on day 1 of the cycle, which is the first day of menstruation, and its entire job is to prepare for what's coming next, ovulation.
So as the hormones from the last cycle just fade away, it's kind of like a set of brakes being released from the pituitary gland. With those brakes off, it's free to let out this small but totally essential amount of follicle-stimulating hormone, FSH. This is basically the starting gun that tells a new group of ovarian follicles, okay, it's your turn. Time to start growing.
This slide shows the beautiful teamwork that's happening inside each of those growing follicles. You could think of it like a tiny factory. One hormone, LH, tells the outer theca cells to make the raw materials, in this case, androgens. Then the other hormone, FSH, tells the inner granulosa cells to take those raw materials and, using an enzyme called aromatase, convert them into the final product, estrogen. Those granulosa cells also send a signal back to the brain called inhibin B that basically says, hey, we've got enough FSH for now, which is a really important step for making sure only one follicle becomes the star of the show.
And get this, it's a parallel process. While the ovary is busy getting an egg ready, the uterus is, at the exact same time, preparing a home for a potential embryo. This rebuilding of the uterine lining, called the proliferative phase, is driven entirely by all that estrogen being pumped out by the dominant follicle. It's perfect coordination. Okay, this brings us to the main event of the entire cycle, ovulation. All of that prep work has been leading up to this single moment, and it's triggered by a really remarkable switch in the hormonal conversation. So, throughout the first part of this phase, estrogen has been using what's called negative feedback. It's basically been telling the brain, hey, calm down, don't release too much LH and FSH. It's a system of really careful control. But when that dominant follicle gets big enough, it starts pumping out so much estrogen that the concentration in the blood stays above this critical threshold, 200 picograms per milliliter for at least 48 hours. And when that happens, something truly incredible occurs. The sustained high estrogen completely flips the script. That negative feedback suddenly becomes positive feedback. So instead of telling the brain to calm down, the message is now a loud and clear go. This estrogen surge makes the pituitary super sensitive to GnRH, causing it to unleash a massive wave of hormones. This switch from negative to positive feedback, it's the absolute linchpin of ovulation. And what's the result of that go signal? Well, you're looking at it. It's the LH surge. A huge, sharp peak in luteinizing hormone acts as the final trigger. About 24 to 36 hours after this surge kicks off, the mature follicle ruptures and the egg is finally released. Ovulation has happened.
So after ovulation, the whole narrative shifts. We go from preparation and action to waiting. We've now entered the luteal phase, as the body creates the perfect environment to sustain a potential pregnancy.
You see, the follicle's job isn't done just because it released the egg. Oh no. The cells left behind go through this amazing transformation, morphing into a structure called the corpus luteum. You can think of it as a temporary but incredibly powerful little hormone factory. Its sole purpose? To pump out tons of progesterone, the new star hormone of this phase.
This slide just perfectly contrasts the two main acts of this cycle. In the follicular phase, estrogen is king. The GnRH pulses from the brain are fast, and the uterus is building itself up. Then, in the luteal phase, progesterone takes over, which dramatically slows down that GnRH pulse generator, and the uterus, it shifts from building to maturing, becoming this nutrient-rich, receptive environment in what we call the secretory phase.
Now, here's a fascinating little detail. While the length of the first half of the cycle, the follicular phase, can actually vary quite a bit from person to person, the luteal phase is remarkably consistent. It's almost always right around 14 days long. And why is that? It's because the corpus luteum has a built-in, pre-programmed lifespan. It's literally on a timer. So, what happens if pregnancy doesn't occur? The system doesn't just fizzle out. No, it executes this precise and very orderly shutdown, which at the same time prepares the stage for the next cycle to begin.
If a fertilized egg doesn't implant and start producing the hormone HCG, that's the one pregnancy tests look for, then there's no signal to rescue the corpus luteum. Its timer runs out, and after about 14 days, it just degenerates. This causes a really sharp, sudden drop in both progesterone and estrogen. And this hormonal withdrawal is the trigger for the end of the cycle.
And that hormonal crash sets off this whole cascade of events. It destabilizes the uterine lining, which leads to menstruation. It also triggers the release of prostaglandins, which cause the uterine contractions we feel as cramps. And critically, this drop in hormones removes that negative feedback on the brain, which allows FSH levels to creep up again, recruiting new follicles and, well, starting the entire story all over again. It's a perfect self-renewing loop. So why does all this matter? What are the big takeaways? Well, first, the menstrual cycle is a vital sign of your overall health, just like your heart rate or your blood pressure. Second, it's just a masterclass in feedback loops, with hormones constantly talking to the brain. And third, because this whole system is so finely tuned, it's really sensitive to disruption. Things like high stress or major changes in nutrition can directly mess with the brain's pulse generator, and sometimes even halt the cycle completely. It's a powerful indicator of the body's overall state of balance. The menstrual cycle is truly a masterwork of biological regulation. By really appreciating its complexity, from the rhythmic firing of neurons in the brain all the way down to the dynamic changes in the uterus, we can start to better listen to the powerful biological story it tells us month after month.